In engineering, design is the process of defining information required to produce an object and archiving it to communicate with others. Now, let's take a look at NEXIVIL's solution for transitioning from analog design methods to digital design method. In this video, there will be a brief overview of digital design including these contents. Design information is evolving from 2D drawings to 3D models, and computers are commonly used to describe them now. The process is gradually transitioning from a method where engineers manually input design details one by one, to tools that automatically generate design information through no-code programs. However, the no-code approach has certain drawbacks including limited functionality, large data volume, and slow execution. These limitations can be solved if engineers acquire the ability to work with programming languages. While learning coding skills requires an additional burden on engineers, it remains the most effective way to efficiently manage and work with digital data. Analog design method leads to a higher likelihood of human errors during the process of generation and delivery of design information. To solve this issue, BIM has been introduced. However, in most cases, drawings are still created and used by analog method. The key to digital design is to convert the process of generating and converting such design information into a digital method rather than an analog method. To handle digital data effectively, customized software is required. Given the wide variety of software available, users need to develop and customize software to suit their specific needs. The time and cost users invest in developing their own software will be recouped as the software automates repetitive tasks. Automation ensures that information flows seamlessly between inputs and outputs, eliminating errors or omissions, all while focusing on digital design data. This approach aligns with the core objective of our digital transformation. These digital design data can be similarly applied to data system of BIM if additional information for each node is incorporated. This ensures that users can more easily access the shape information of the target structure and efficiently utilize the data, as managing nodes in groups enhances accessibility and usability. Digital design procedure can be separated in two main parts, and the first step is to define digital design data. The digital design data consists of extensive coordinate information and physical properties of the target structure. To ensure the efficient generation of this information, we recommend leveraging parametric design methodologies that incorporate constraints and data point correlations. An essential skill for generating large volumes of design data with a limited set of parameters is the mathematical ability to define and utilize constraints and correlations, an ability that is intrinsic to engineers. In other words, successful digital design requires a combination of mathematical problem-solving skills and coding expertise. To simplify this process, NEXIVIL offers tools to normalize parameters using Excel spreadsheets, making parameter definition more intuitive and user-friendly. The second phase of digital design involves utilizing the digital design data defined in the previous step to produce end-user outputs, such as 2D drawings and 3D models. For 2D drawings, the symbols and expressions used in each industry must adhere to established protocols, and 3D models must comply with the IFC standard classification. NEXIVIL enhances the convenience of digital design by offering data generation modules tailored to each standard. In addition, the second stage of digital design can extend into areas of integration and interpretation if advanced engineering technologies are applied. In other words, the digitization rate increases by integrating various software solutions related to digital design data. NEXIVIL applied the digital design concept to designing bridges and tunnels first. by the template automatically generating detailed drawings and 3D models aligned with the structural element information. Users could maximize work efficiency while minimizing human error. From simple to highly complex structures, we have validated the flexibility of digital design methods, and the number of users continues to grow. For more details, subscribe our YouTube channel, where we will regularly share updates. Your support means the world to us. Experience the digital design with NEXIVIL.